Yellowstone National Park officials report that hundreds of earthquakes have hit Yellowstone. In the intricate tapestry of Earth's geological phenomena, Yellowstone National Park stands as an unparalleled testament to both the sublime beauty and latent hazards that nature can harbor. As the custodian of the oldest national park in the world, established on March 1, 1872, by President Ulysses S. Grant, Yellowstone transcends its designation as a haven of wilderness, geysers, and wildlife. This expansive marvel, spanning over 2.2 million acres across Wyoming, Montana, and Idaho, conceals a geological secret that beckons the discerning gaze of scientific inquiry. This geologic masterpiece, although admired for its serene landscapes and diverse ecosystems populated by grizzly bears, wolves, and herds of bison and elk, harbors a profound duality. Yellowstone, fundamentally, is not solely a park, but an immense volcanic caldera, distinguished as one of the largest active volcanic systems globally. Within this dichotomy lies a narrative that extends beyond the conventional perceptions of natural beauty and ventures into the realm of seismic unrest, capturing the attention of scientists worldwide. Recent seismic activities within the Yellowstone National Park have precipitated a surge of scientific vigilance and inquiry. The compendium of tremors, veiled beneath the iconic geysers and hot springs, has provoked contemplation regarding the potential implications for both the park and, intriguingly, the global geophysical landscape. To comprehend the gravity of these seismic events, it is imperative to navigate through the contextual history that envelops Yellowstone and discern the nuanced interplay between its scenic allure and its geological volatility. Within the dynamic dance of geological occurrences, the Yellowstone Volcano Observatory stands as a mysterious conductor directing a symphony of geysers, including the renowned Old Faithful and the captivating Grand Prismatic Spring. In this intricate ensemble, the Yellowstone caldera, a colossal supervolcano, seizes attention as a geological phenomenon of unmatched scale and significance. To undertake an academic exploration of this colossal caldera, we traverse the records of its tumultuous geological history, a narrative shaped by 3 consecutive super-eruptions unfolding over the past 2.1 million years. The genesis of Yellowstone's colossal caldera unfolds in epochs marked by cataclysmic eruptions, each leaving an indelible imprint on the landscape. Commencing 2.1 million years ago, the inaugural eruption forged the Huckleberry Ridge Tuff and bestowed upon the Earth a caldera spanning more than 60 miles. The second convulsion, transpiring 1.3 million years in the past, sculpted the Island Park caldera and begot the Mesa Falls Tuff. The most recent paroxysm transpired approximately 640,000 years ago, begetting the Lava Creek Tuff and crystallizing the contemporary Yellowstone caldera. This formidable eruption expelled over 240 cubic miles of rock, ash, and volcanic gases into the atmosphere, initiating a global cascade of consequences that reverberated across ecosystems. Consider, if you will, the enormity of a force capable of enveloping an entire continent in ash, inducing a global climate disruption and heralding widespread destruction. The ashfall resultant from such an eruption possesses the capacity to entomb cities and farmlands, precipitating catastrophic repercussions for agriculture and infrastructure. The release of sulfur aerosols, orchestrating a phenomenon known as a volcanic winter, further amplifies the geological reverberations, cooling the planet and manipulating weather patterns for protracted intervals. Yet, the narrative extends beyond this precipice. In the realm of subterranean complexities that define Yellowstone National Park, recent scholarly investigations have unearthed a revelation of profound magnitude. The canvas of geological intricacies unfolds to unveil not merely one, but 2 subterranean reservoirs of molten rock beneath the expansive Yellowstone volcano. The initial magma chamber, first documented in the 1980s, resides approximately 10 kilometers below the Earth's surface, harboring a voluminous 10,000 cubic kilometers of molten material. However, a seismic odyssey has probed even deeper, unraveling a second magma chamber ensconced between depths of 20 to 50 kilometers, an astounding revelation that dwarfs its shallower counterpart by a factor of 4.5. This deeper reservoir, unveiled through meticulous seismic imaging, ushers in a new epoch in geological comprehension. Collectively, these subterranean chambers embrace a reservoir of molten rock of such staggering proportions that it could fill the Grand Canyon nearly 14 times over. While the existence of these chambers does not escalate the probability of an imminent volcanic eruption, it bears implications of perpetual significance. The shallow magma chamber, situated closer to the Earth's surface, stands as a dynamic source capable of periodic replenishment, endowing the geothermal features of the park with a continuous fount of energy. Delving into the geological theater of Yellowstone, situated at the heart of America's inaugural national park, recent occurrences have thrust this landscape into the limelight. A seismic drama, unfolding within a span of a mere 12 hours, has ensnared both scientific cognoscenti and casual observers alike, commencing on March 28th with a seemingly inconspicuous magnitude 0.7 earthquake. This heralded the initiation of an extraordinary seismic series. Within this temporal ambit, a cascade of no fewer than 60 earthquakes, spanning magnitudes from 0.1 to 3.7, was recorded. Noteworthy among them were two earthquakes surpassing a magnitude of 3.0, with the most formidable registering at 3.7, at precisely 8:24 a.m. MDT, a seismic concerto that has set the stage for rigorous scientific inquiry and public apprehension alike. What enigmatic forces lie dormant beneath the seemingly tranquil veneer of Yellowstone National Park, raising the specter of a cataclysmic eruption? Contemplating the prospect of such an event is not merely an exercise in scientific curiosity, but an earnest inquiry into the potential consequences that would befall this iconic geological landscape. The very notion of an eruption in Yellowstone elicits not only a sense of awe at nature's ferocity, but also a sobering recognition of the profound implications such an event would have on both the immediate surroundings and the broader human landscape. An eruption within the confines of Yellowstone National Park holds unparalleled implications, transcending the boundaries of routine seismic occurrences. The sheer magnitude of such an event would usher in an era of devastation within the park's proximal zones. Lava flows, pyroclastic surges, and a relentless deluge of volcanic ash would conspire to erase the very features that render the landscape iconic. The rich biodiversity, the picturesque panoramas, and the world-renowned geysers would succumb to the relentless forces of an unleashed geological fury. Yet the ramifications extend beyond the natural realm, entwining with the intricate fabric of human activity. Yellowstone and its surrounding regions serve as a magnet for millions of tourists annually, drawn by the allure of this geological marvel. The prospect of a volcanic cataclysm raises poignant questions about the potential human toll, the resilience of infrastructure, and the subsequent societal repercussions. In contemplating the implications of a Yellowstone eruption, one is compelled to confront not merely the geological forces at play, but also the intricate interplay between nature's might and humanity's vulnerability in the face of such elemental forces. Within the discourse of potential geological upheavals, a dispassionate scientific examination of the ramifications stemming from a prospective supereruption at Yellowstone National Park reveals a cascade of consequences that extend far beyond the immediate vicinity. In scrutinizing the potential impact on towns and communities proximal to the park, the scientific inquiry invokes a sobering assessment of the monumental challenges associated with evacuation efforts. This assessment gains further gravity when considering a model predicting the aftermath of a Yellowstone supereruption, indicating that the fallout could extend to affect 3/4 of the contiguous United States. Furthermore, an alarming statistic emerges, suggesting that within a radius of 1,000 kilometers from the eruption, up to 90% of the population could face fatality, a testament to the profound and far-reaching consequences of such a cataclysmic event. The specter of widespread ashfall, a distinctive hallmark of super-eruptions, emerges as a pivotal aspect of concern. Forecasts grounded in scientific models delineate a scenario wherein a Yellowstone eruption could propel thousands of cubic kilometers of ash into the atmosphere, precipitating a colossal atmospheric blanketing over vast expanses of North America. Delving into the specifics, mapping projections underscore the potential for regions as distant as Missouri and Texas to grapple with accumulations exceeding 10 centimeters of ash. Conversely, locales in closer proximity to Yellowstone could confront the staggering prospect of being submerged under several meters of ash, exacerbating the complexity of post-eruption recovery efforts. Moreover, the release of prodigious volumes of volcanic gases and aerosols into the stratosphere bears multifaceted consequences for global climate dynamics. Sulfur dioxide, a chief protagonist in this atmospheric interplay, has the capacity to foster a veil of aerosols that reflects sunlight, consequently inducing a pronounced cooling effect on the Earth's surface. Scientific analyses project that a Yellowstone supereruption could catalyze a diminution of global temperatures by up to 12 degrees Celsius over several years, a phenomenon colloquially referred to as a volcanic winter. This protracted climatic disturbance could intricately intertwine with weather patterns, instigating a ripple effect on agricultural productivity and potentially instigating food scarcity in diverse regions across the globe. In the scientific contemplation of these multifaceted repercussions, the Yellowstone supereruption emerges as an intricate nexus of geological forces with profound implications for local and global ecosystems alike. Against the backdrop of Yellowstone's geological intricacies, a discerning examination of the supervolcano's current seismic activity prompts reflections on the delicate equilibrium between nature's forces and human vulnerabilities. Perched upon a hotspot, a conduit of molten rock ascending from the Earth's mantle, Yellowstone stands as a unique geological canvas, showcasing both the park's geothermal wonders and the inherent volcanic activity shaped by this subterranean plume. Notably, this hotspot distinguishes itself by its location beneath a continental crust, a distinctive feature in contrast to its oceanic counterparts. The recent surge in seismic events along the eastern fringe of the Yellowstone caldera, proximate to the site of the last major eruption, has resurfaced contemplation regarding the supervolcano's dormant state. The pertinent question lingers: are these tremors indicative of an impending awakening, or are they manifestations of the Earth's enduring potency and capriciousness? In navigating this discourse, a succinct yet insightful exploration of Yellowstone's geological complexity is essential to glean nuanced perspectives on the present tremors and their implications for the future. Scientific scrutiny intensifies as seismologists and geologists meticulously parse through data, scrutinizing for discernible patterns and indicative clues that may signal shifts in the volcanic system's behavior. The collaborative efforts of the University of Utah seismograph stations and the Yellowstone Volcano Observatory serve as stalwart sentinels, assuring the public that the recent surge in seismic activity does not foreshadow an imminent eruption. Rather, these seismic events are attributed to the orchestrated dance of fluids and gases beneath the Earth's surface, a natural phenomenon within this geologically dynamic enclave. The park's captivating geothermal features, including geysers and hot springs, extend beyond their role as tourist attractions, serving as tangible indicators of the fervent geological undertakings transpiring beneath the surface. Within this framework, the occasional hydrothermal explosions, born from the rapid conversion of superheated water to steam below the Earth's surface, present a tangible manifestation of the region's ceaseless geological dynamism. Despite their annual recurrence, these smaller hydrothermal explosions, analogous to sporadically robust or unconventional geyser events, harbor inherent hazards for those in proximity. Illustratively, the vestiges of a hydrothermal explosion at Porkchop Geyser in the Norris Geyser Basin in 1989 remain conspicuously visible, manifesting as scattered rock debris encircling the central spring, a poignant reminder of nature's volatile temperament. Extending further back, the geological canvas within Yellowstone recounts a more significant explosion, forming a crater merely 3,000 years past, a testament to the enduring dynamism of this geologically animated landscape. In the geological tapestry of Yellowstone, the specter of landslides looms as a formidable hazard, entwining the precarious interplay of unstable terrain, weathering effects, and seismic activities. These landslides, sudden and catastrophic in nature, hold the potential to disrupt thoroughfares and trails, isolating segments of the park and posing substantial risks to both hikers and motorists. The compounding influence of tremors and earthquakes further exacerbates these geological dynamics, capable of not only reshaping geysers and hot springs, but also instigating landslides with enduring repercussions. A resonant echo of Yellowstone's seismic past reverberates in the collective consciousness embodied by the Hebgen Lake earthquake, an epical seismic event etched in the annals of the park's history. With a magnitude of 7.5, this seismic upheaval stands as the most substantial earthquake recorded in the region. The cataclysmic aftermath bore witness to massive landslides, including one that dammed the Madison River, giving rise to the formation of Quack Lake. Hurtling down the Madison River Canyon at a staggering estimated speed of 100 miles per hour, the landslide carried a colossal payload of approximately 80 million tons of rock, soil, and debris. The ensuing tragedy claimed the lives of 28 individuals, burying a campground and leaving destruction in its wake, not confined to the immediate vicinity, but extending to distant locales. This seismic watershed also left an indelible mark on Yellowstone's infrastructure. Roads, bridges, and buildings bore the brunt of the earthquake's force, with lasting impacts on visitor access and park operations. The geothermal features, emblematic of Yellowstone's geological allure, underwent profound transformations. Long dormant geysers suddenly erupted, altering the established patterns and behaviors of others. The iconic Old Faithful geyser, in particular, saw its eruption intervals disrupted, and the park witnessed the emergence of new hot springs and fumaroles. The aftermath of the Hebgen Lake earthquake prompted a comprehensive reevaluation of seismic risks within Yellowstone, catalyzing significant enhancements in monitoring and preparedness. Collaborative efforts, spearheaded by the U.S. Geological Survey and other agencies, resulted in heightened vigilance through expanded monitoring initiatives. The seismic lessons learned ushered in updates to building codes and emergency response plans, offering a testament to the enduring resonance of geological events in shaping the trajectory of Yellowstone's future. In the unfolding narrative of Yellowstone's enigmatic wonders, the attentive gaze of scientists converges with global anticipation, poised on the threshold of revelations yet to be unveiled. A potential key to these revelations may lie within the dynamic realm of Yellowstone's wildlife, which traverses diverse landscapes, from dense forests to open meadows, from steaming geysers to icy rivers, providing a sanctuary for an extensive array of plant and animal species. Recent peculiarities, however, have cast a shadow upon this harmonious tableau. Reports of unconventional wildlife encounters, particularly with bison, have punctuated the park's recent chronicles. Just weeks ago, a disconcerting incident unfolded when a woman faced a grievous encounter with a bison despite repeated warnings and close calls. Tragically, another incident transpired last week on the Buttermilk Trail, culminating in the discovery of a deceased woman 8 miles from West Yellowstone. Investigative efforts revealed grizzly bear tracks at the scene, pointing towards a fatal bear encounter. In response, the area has been temporarily sealed to human presence, underscoring the imperative of ensuring both human and bear safety. Investigations into this incident persist, shrouded in the ongoing quest for clarity. Amidst the uncertainties, a lingering question endures. Is there a nexus between the recent wildlife anomalies and the seismic activities beneath the park's surface? While the jury remains deliberative, certain experts posit that animals, attuned to the rhythms of the land for millennia, may be discerning subtle cues imperceptible to human senses. The notion that animals possess an innate capacity to detect seismic activities predates these recent events, substantiated by documented cases wherein animals exhibited atypical behavior prior to earthquakes. Instances include the dogs incessantly barking or cats seeking refuge, an intriguing correlation that elevates the discourse surrounding Yellowstone's fauna beyond mere observation to a nuanced exploration of their potential role as seismic sentinels. Yellowstone's ecosystem, shaped by geothermal features and seismic activities, reflects a profound connection with wildlife, especially the bison. Recent changes in animal behavior, particularly among bison, prompt questions about responses to underground shifts or imperceptible environmental changes tied to magma chambers. Scientists seek correlations between animal behavior and seismic data, unraveling the intricate relationship between fauna and Yellowstone's subterranean dynamics. This interconnected web of wildlife, rivers, geysers, and earthquakes poses inherent risks, urging authorities to employ rigorous measures for understanding, monitoring, and mitigating potential threats in this geologically active region. The Yellowstone Volcano Observatory, YVO, and its partners have unveiled a comprehensive monitoring plan designed to enhance surveillance and hazard assessment in the Yellowstone region. The plan comprises 2 focal components: backbone monitoring and hydrothermal monitoring. Backbone monitoring encompasses the existing region-wide surveillance network dedicated to monitoring seismic activities, ground deformation, and geological phenomena in the Yellowstone Plateau. This network, composed of strategically positioned seismometers, GPS stations, and other instruments, furnishes real-time data on subsurface geological activities. The plan outlines a decade-long initiative to fortify and modernize this surveillance infrastructure. Introducing a novel facet, hydrothermal monitoring will scrutinize Yellowstone's thermal and geyser basins. Through the measurement of temperature, pressure, water chemistry, and other parameters, this monitoring system aims to offer valuable insights into the hydrothermal system's behavior. Its role is pivotal in detecting any unusual changes that might signify an impending geological event. Collaboratively led by the University of Wyoming, alongside esteemed scientific agencies like the U.S. Geological Survey and the National Park Service, this monitoring endeavor underscores a collective commitment to comprehending and mitigating geological hazards within the Yellowstone Plateau region. The ongoing subscription to Beyond Discovery signals an ongoing exploration of these scientific frontiers.